Well, dear students, see, although the expansion or compression or calculation of work energy, it is for real gas is not in your syllabus, but in some books you may find to calculate the work for van der Waals gas. And you know, in van der Waals equation of a state, you have different possibilities that sometimes force of attraction is there, sometimes force of repulsion you are considering, sometimes both were considering. So you have different equation of a state you can change, or examiner may give you some hypothetical expression for which the work calculation can be asked. So for that purpose, I am just giving you introduction. All of you are knowing well how to calculate the work. I am just giving you the idea how to use the equation and calculate the work, right? So suppose that we have a real gas. So definitely real gas will have certain equation, and a well-known equation we have, that is van der Waals equation. So the van der Waals equation is P plus n square A by V square V minus NB is equal to nRT. Suppose that any gas obeying this equation of state, and your task is to calculate the work in the reversible process, expansion or compression work. So see, formula is same. What formula? Formula is delta W reversible is equal to minus, this is convention, P external 1 to 2 dV, right? Means you have this equation. Process is reversible, so you can use P external is equal to P gas plus minus dV, and this is equal to P gas, you can write. This thing is clear? Any doubt? Hopefully there is no doubt. Okay, now whatsoever equation is given to you, okay, whatsoever equation is given to you, you have to rearrange that equation in terms of pressure. Means what you have to do, keep pressure in the left and shift all the terms from the equation in the right hand side. So equation 1 you can rewrite, equation 1 you can rewrite P is equal to nRT by V minus NB, right? And minus n square A by B square, right? So this you can make equation 3. Temperature is constant, isothermal, means T is constant, R is constant, N is constant, B is constant, A is constant. The only variable here is V, right? And P also here. So pressure of gas, you have rearrange this equation. If gas is obeying this equation of state, then you have rearranged this, put this value here. So what is the concept? Whatever equation, any hypothetical equation is given, what you can do, you just rearrange the equation, keep the pressure in the left hand side, rearrange all other terms of the equation, transfer to them in the right hand side, and evaluate the formula for gas. If it is required, you can divide the equation, you can multiply the equation if it is required, right? And make the formula for P gas. And now this, you can put this P gas here and integrate and get the formula, right? So from equation 2, you can write W reversible is equal to minus 1 to 2 nRT by V minus NB minus N square A by V square dV. Now all of you are knowing the mathematics, and you can what evaluate for integrate this between these two limits 1 and 2. Variable is V here, and all other terms are constant. So W reversible is equal to minus, I am writing directly formula, minus N or nRT 2.303 log V2 minus NB by V1 minus NB, right? V2 minus NB minus by V1 minus NB, okay, plus N square A 1 by V2 minus 1 by V1, right? Right? So this is equation number 4. By using this equation, you can calculate the work involved in the reversible process. So V2 is given, V1 is given, A and B is given, N is given, T is given. So you can calculate this work, right? Suppose that examiner given that a gas obey this equation of state. This equation of state P V minus NB is equal to nRT. Suppose that examiner has given this equation. Evaluate work. So this term is there, this term is not there. So what should be the formula for this? This term is there, this term is not there, n square a by b square term is not there. So eliminate this equation, this term from here, and you will get. So I am writing directly here the formula. Now you can convert this formula for P gas. P gas is equal to nRT by V minus NB, right? So now your formula delta W reversible, this is equal to minus 1 to 2 P gas, you can put this nRT by V minus NB into dV. Now you can integrate this. So this is the second case. So minus 2.303 nRT log V2 minus NB by V1 W reversible, right? So in this way you can calculate. Similarly, this term is not there, only this term is p plus n square by n square a by b square into v is equal to rt is given, or any other equation is given. You just convert that equation in terms of pressure and then evaluate, right? No problem. So this is the work involved in the expansion or compression, isothermal expansion or compression of a real gas. Now, what about internal energy? Change in internal energy, delta E, at constant temperature, it is zero for real gas or non-zero? Tell, dear students, think. I have already told you. What is the change in internal energy if a gas expands or compressed isothermally? What is the change in internal energy? If the behavior of the gas is ideal, then it is zero, right? For ideal, right? At constant temperature. But delta E is not equal to zero for a real gas, right? At constant temperature. Then how to evaluate what is the value of this? So we have this formula, delta E. I have already told you, delta E is equal to del E by del T at constant V, delta T plus del E by del T, del V at constant T d, right? We have this formula. At constant, temperature, this term is zero. When T is constant, so dt is equal to zero. Dt is equal to zero. So this term is zero. So delta E is equal to, and this del E by del V, energy by volume, this I have already told you is equal to N square A by V square. Internal pressure. This is called internal pressure, right? So you can put here, and how to write this, as all of you are knowing that this is a state function, so you can write T and V and constant, right? So we can write here N square A by V square into dV, right? Into dV. So the change in internal energy with the change in volume, so we can put this. So negative sign will come here because with the increase in volume, internal energy will decrease. So negative sign will come here. We can write this. So minus 1 to 2 N square A dV by V square. Now integrate this and get the answer. So minus N square A 1 by V2 minus 1 by V1, right? So this is the change in internal energy. This is equation 6. Change in internal energy in internal energy For real gas, this is very important. Otherwise, with change in volume, with change in volume for at constant temperature, at constant temperature, right? So by using this equation, you can calculate. Now you have calculated change in energy, you have calculated work, so you can calculate heat. So apply thermodynamics first law. So delta E is equal to delta Q plus delta W, right? So delta E is equal to minus n square A 1 by V2 minus 1 by V1 is equal to or we can write here minus delta W is equal to delta Q, right? Now put the value of W here. We have already calculated this equation. So minus n square A 1 by V2 minus 1 by V1 minus nRT. So minus this is plus nRT 2.303 log V2 minus NB by V1 minus NB. This is N, right? And this is minus, so this is plus. Basically, plus n square A 1 by V2 minus 1 by V1, right? This is equal to delta Q. So this term is cancelled. So delta Q is equal to 2.303 nRT log V2 minus NB by V1 minus NB, right? So this is equation 7, and this can be used to calculate the change in internal energy, change in heat change in the isothermal expansion or compression of any real gas, right? So these are the formula we can use to evaluate Q, uh, internal energy and work in the expansion or compression of certain real gas. Although this is not directly mentioned in your syllabus, right? Okay, good. So I am closing this calculation for real gases here only, right? Okay, now see, I am taking another thermodynamic function that is called enthalpy, and already I have introduced this enthalpy to you, but now we will discuss more detail about this term enthalpy. Uh, if you see, enthalpy and energy both have same unit, means this is also a form of basically energy, and it is represented by H, and it is basically function of H is the function of T and P. It is defined in this way, right? For 1 mole, or if N is constant. So this is first feature of H, that it is a state function, that is state function, right? And extensive, H is extensive, but per mole H by N, where N are the number of moles present in the system, this is intensive. Intensive, right? Okay. So, and it is defined at constant pressure, basically. So, see, it is the function of T and P, like internal energy, the function of T and V. Similarly, it is defined at T and P, right? See, chemical reactions, biological processes usually takes place under this constant pressure, right? So, this is more useful term for evaluating the energy change of the system. So basically this enthalpy tells about nothing but energy change. So enthalpy, this will tells about the energy change of system only. These functions are designed for system only. Change of system at constant pressure, at constant pressure, right? So at constant pressure, what is energy is changing of the system, that is quantitatively estimated in terms of enthalpy. And at constant volume, what is energy changing of the system, that is quantified with the help of internal energy. So this is the pinpoint difference between enthalpy and energy. Again, I am repeating, this function, thermodynamic function, defines the energy change of the system at constant pressure. That's it, right? So H and E are related with this equation, simple equation. All of you are knowing, if pressure is constant, then the PV work is default there. How to make the pressure constant? Remember, I have already told you in CP and CV, in the explanation of CP and CV. When you are designing a constant pressure system, so PV work is there, and we are considering here only PV work, right? So PV work is default in every constant pressure system. Either piston will move up or down as per the requirement of the system, because pressure is constant. And how to make the constant pressure system isobaric system? You have to take some cylinder and put massless, frictionless piston uh, over the cylinder, so that it can move up and down to make the pressure constant. And whenever piston moves up and down, definitely PV work there. So in constant pressure condition, under constant pressure, constant pressure condition, PV work is there, right? Constant pressure condition. PV work, PV reversible work is there, right? So this H and E are defined as like this mathematically: H E plus P, right? Under constant volume, energy change E, and the difference of constant volume and constant pressure, what I have explained in CP and CV, the same thing. Only this PV work differs H and E. If you subtract PV work from H, you will get what? Internal energy change. Or if you add PV work in the internal energy, then you will get enthalpy. So this is the difference. So if you take a gas like this, have pressure P, temperature T1, volume V1, right? And changes reversibly, constant P. So here also the gas pressure is P, temperature T2, and volume V, right? So here the internal energy is E1, and here the internal energy is E2, right? E1 and E2. So we can write here thermodynamics first law, delta E is equal to delta Q plus delta W, right? And this is equal to, we can write delta Q at constant P, and in this place of this we can write minus P dV, right? P delta V, constant pressure, P delta V, right? Clear? Okay. So we can write here delta E, this minus, bring this side, so plus P delta V is equal to delta Q at constant pressure, right? Or we can write here, or delta E plus delta PV is equal to delta Q at constant pressure, or we can write delta E plus PV is equal to delta Q. So at this place we can write H. So delta H is equal to delta Q at constant pressure is equal to NCP delta T, right? NCP delta T. So this is the master equation. Here only you can only take what? PV work, not any other kind of work. Now see, different formula we can prepare here. So what we can write here? Delta H is equal to, we can write here one more formula. This is the master formula. One more formula we can write, delta H is equal to delta E plus delta PV. right? Now constant pressure condition, so P delta V you can put here. So this is the general relation between delta H and delta E. Now we have this formula PV is equal to nRT. So we can write here delta PV is equal to delta nRT. Now in the right hand side, if you see carefully, N is for gas or for any matter, you can take liquid or solid. No, this is for gas only. So if you have a gaseous chemical reaction, so you can use this formula at constant temperature if number of moles are changing, and if you have a system like gas is expanding or compressing only, so temperature changes there. So you can make another formula here, that is delta E plus delta NGRT plus NR delta T. This is equation 3, right? In place of this, we can change this. Why I have written here delta Ng? Because in this equation only gaseous moles will come, not for liquid or solid. And what is the delta Ng? How to evaluate delta Ng? So delta Ng is the sigma of gaseous product in any chemical reaction minus sigma of gaseous reactant, right? So this means you can evaluate delta Ng for any gaseous reaction, and you can evaluate delta H for that reaction. If delta E is given or if delta H is given, then you can evaluate. See, usually constant temperature condition is given for gaseous chemical reactions. So this term is 0. So at constant temperature, equation 3 becomes like this. At constant temperature, equation 3 is like this. Delta H is equal to delta E plus delta NGRT, right? So for any chemical reaction, you can use this equation. For chemical reactions, and chemical reactions default condition is constant T and constant P. So chemical reactions generally carried out under constant temperature and constant pressure condition. So this function you can use, this equation you can use for any chemical reaction. So if the question arises that for any chemical reaction, this delta H and delta E are same or different, so this delta H and delta E may be same or may be different, right? Suppose that if delta Ng, first case we can use, if delta Ng is equal to 0, means from here you can evaluate that number of gaseous, suppose that if we take a reaction H2 gas plus Cl2 gas gives 2HCl gas. Suppose that this equation is given. So what is delta Ng for this reaction? Delta Ng is equal to 2 moles of the product, 2 minus 1 of this, balance equation you have to take. So this is equal to 0. So if delta Ng is equal to 0, so delta H is equal to delta E. Means internal energy change and enthalpy change both can be equal for any gaseous reaction in which delta Ng is equal to 0, means left hand side gaseous moles and right hand side gaseous moles if are equal, then delta H means heat energy change at constant pressure and energy change at constant volume both are same for the given reaction, chemical reaction, right? Clear? Other reactions, suppose that if you are taking any reaction like this, uh, NaOH aqueous plus HCl aqueous gives NaCl aqueous plus H2O, already it is aqueous. So for this, what is delta Ng? Delta Ng is equal to 0. Hmm? Delta Ng is equal to 0. So if delta Ng is equal to 0, so this delta H is equal to delta E, right? So delta Ng is equal to 0. We have two conditions. Delta Ng is equal to 0 if there is no gaseous reaction. So this is non-gaseous reaction. Non-gaseous reaction. So for non-gaseous reaction or gaseous reaction for which left hand side and right hand side have same number of gaseous moles, then delta H and delta E are equal. Clear to everybody? Okay. And if second case, if delta Ng is equal to is greater than 0, means delta Ng is positive, so definitely delta H is more than delta E, means delta H and delta E are not equal and delta H is more than delta E. And if delta Ng is less than 0, then delta H is less than delta E. So delta H and delta E for any gaseous reaction or for any reaction, it may be equal and it may be not equal. Suppose that one example is given that PCl5 solid, this will dissociate into PCl3 solid plus Cl2 gas. What is the relation between delta H and delta E? So first evaluate delta Ng, this is equal to 1. So delta H is, what is the relation? Delta H is more than delta E, right? Delta H is more than delta E, right? So this, this type of questions you may get, and you have to write the balanced chemical equation, and then calculate the difference of delta H and delta E, or use the equation. For example, another equation we can take. Find the difference of uh, delta H and delta E for the combustion of 1 mole of liquid benzene at 300 Kelvin, right? Suppose that this question is given. So what you have to do, first you have to write the equation. C6H6 liquid, because you know room temperature 300 Kelvin is the room temperature, and at this temperature this is liquid plus O2 gas gives CO2 gas plus H2O, 300 Kelvin, H2O is liquid, right? So you have to write a proper chemical equation, balance this 6 CO2 and 3 H2O, and this is 15 by 2. Now this is the balance equation for 1 mole of this liquid benzene. So delta Ng is equal to 6 gaseous moles this minus 15 by 2. So this is minus 3 by 2, right? So what is the difference of delta H and delta E for this reaction? So delta H is equal to delta E plus delta NgRT. So delta H minus delta E is equal to minus 3 by 2 RT, right? Now you can put the value of this. So this is minus 3 by 2 into 8.314 joules per mole per Kelvin. This is 3 by 2 mole into 300 Kelvin. So Kelvin cancel, moles cancel. So this 150. So 150 multiplied by 8.314 multiplied by 3. So this is equal to 37 minus 3741 joules. So this is equal to minus 3.741 kilojoule, right? So you can write here that delta H is less than delta E. Means when you evaluate experimentally the delta H and delta E for this combustion of 1 mole of benzene at 300 Kelvin. So your delta H is less than delta E by this kilojoule, right? So in this way you can evaluate or link, or you can make the relation between delta H and delta E, right? See, one very special case we have that work calculation of work in the gas production. Suppose that any chemical reaction is given, so we can use this formula P delta V is equal to delta NGRT at constant temperature. We can use this equation for the calculation of work, right? Suppose that if we have a container, open container, suppose that first I am considering a closed container in which volume is fixed. Suppose that some some reaction is taking place here inside this closed container. Some gas is producing here. Suppose that if we are taking here Fe plus HCl, so hydrogen gas is released. So hydrogen gas is released from here, but the volume is constant, so there is no PV work. So no PV work, no PV work. Why no PV work, right? So the question arises why? Because in this case dV is equal to 0, volume is constant, right? But if we take open container, imagine open container. So in open container, when the same reaction we set up iron plus HCl, so in open container, when you take this, atmosphere is there, atmospheric pressure is there, atmosphere is there, this is atmosphere, you cannot replace this. And now this hydrogen gas is released. So when hydrogen gas will release, this will push the atmosphere. So basically the PV work in this case is due to the pushing of atmosphere upward. But in this case, to calculate the change in volume is very difficult. What should be the change in volume? So delta V calculation is difficult. Delta V calculation is difficult. But we can calculate this delta ng. This is a very good variable here which we can calculate, and by using this equation we can calculate the work. What is the problem? No problem. So in such type of cases, work, we can assume this a very slow process, reversible. So this work is equal to, we can write here, minus P external, this atmospheric pressure, into delta V, and this we can replace with what, this delta NGRT, minus delta NGRT. So we can calculate the expansion work by using this equation, delta NGRT, right? So this is equation 2. By using this equation you can calculate, and extra care should be taken in the calculation of delta ng. For example, if we take a question that calculate the work done, calculate the work done when 50 gram of iron reacts with, when 50 gram of iron reacts with dilute HCl at 298 Kelvin, right? Okay. First, in a closed vessel or closed container, closed vessel, and number 2, open vessel, right? Suppose that this question is given. So what you have to see here, when you take this in a closed vessel, dV is equal to 0, so work WPV is equal to 0 in case A. In case B, what you have to do, first you have to write the equation, Fe solid plus HCl dilute, FeCl2 aqueous plus hydrogen gas, right? And 2 HCl here. This is also aqueous, not gaseous. Now see here, 1 mole of this produces 1 mole of hydrogen. So basically you need here delta Ng. If suppose that in this question some other gaseous products are there, so then you have to add. And suppose that if you have already some gaseous reactant, then it is very difficult for here to evaluate the system, the work in this case, right? So suppose that some more gaseous products are there, then you have to take consider those gaseous moles as well. So delta Ng is equal to, here you can write here, moles of hydrogen, and moles of hydrogen is equal to moles of iron as per this balance equation. So moles of iron you can calculate from here, 50 by 50 gram divided by 55.85 grams per mole. So you have calculated delta Ng here. So the PV work involved here is equal to minus delta NGRT. So this is equal to minus of this N 50 by 55.85 moles into R 8.314 joules per mole per degree Kelvin into temperature 298 Kelvin moles. So this is equal to minus 2.2 kilojoule, right? So this is the answer. So in such type of cases, it is very important to evaluate delta Ng, right? If you have evaluated delta Ng, temperature is constant. So in open vessel, you can calculate the work involved, right? So this is a very special case of the calculation of PV work, right? Okay, good.